Okay, it is recording now. Here we go. Actually, it looks like it is recording now. Fingers crossed. Strangely, nobody in the digital world at the moment. All righty, everybody. Good morning. Good morning. Oh, my. That's awful again today. 2 days in a row. Let's try that again. Good morning, everybody. Good morning. What's that?
It's called being tired.
Tired? Tired? How could you possibly be tired? You had all kinds of time to do your months in advance. Nothing but time on your hands. The world is your oyster. So just try to remember, there turns on not sleeping enough. So be very careful of missing out on sleep. That's definitely important. All right, so I think in an effort to get everybody to wake up a little bit more today we need to be dialed in. We're going to do the wave. And the wave is first we're on this side, and we go this way, and it's arms only, no standing. And you got to say, wee, as the wave goes by. And don't do it lose attendance. Ready? Starting on this side. Ready? 1, 2, 3. Wee! There we go. Awesome. That was pretty good. All right, this side. Come on, wait. 1, 2, 3, go. Wee! Awesome. Very good. All right. Now, are we feeling a little bit better? Okay. Good morning, everybody. See, great flow helps. Totally wakes you up. It's a big difference. So feel free to do the wave in future classes. All right. So let's take a look at what we're going to be talking about today. We are going to be without Brian today, which is always sad, but he is not available, and we will have to make do. All right, let's get into today's material. And oddly enough, I think we're going to be all right. Okay. Here we go. All right, lecture 8. Now, 8 is very exciting because we are going to be talking about UV mapping. Oh, yes, the much awaited UV mapping. Now, trust me on this one. When it comes to UV mapping, it is a fairly technical process. However, luckily it's very repetitive. We do the same thing again and again and again. That's repetitive. And it's very important that you have the steps for UV mapping job. So when I say, and these are the steps for whatever process, that's when you really absolutely must write down the steps, because any information you are missing will stop you dead in your tracks and you will not be able to complete the process. And UV mapping is frustrating enough on its own. I don't have all the steps. Does that make sense? So the concept of UV mapping is fairly straightforward. It's not that bad. And I do my best to make it very simplistic. However, when you get to the actual steps, you can't kind of find your way through it. You literally, if you are missing a step, you stop that in your tracks and you can do absolutely nothing until you get the information you need, which could be 24 to 48 hours later. Does that make sense? So make sure we are dialed in today, we have our A game going, and we're taking excellent notes because it's going to make a huge difference today above all days. All righty? Get a hell yeah on that? Oh, it was a somber hell yeah, but I got one. All right. So let's talk about this UV mapping. UV mapping is basically the process where we take a complex 3D surface and we sort of lay it out flat so that we can paint textures on it. and then we can sort of wrap it back around the object that we are trying to create a texture for. So just to give you an idea, imagine how difficult it would be to paint on a box, right? A box would be very challenging to paint on. But if I cut the corners out of the box, right, and lay the box out flat, then it would be really easy to paint and draw on, right? Because it's flat, it's like paper, something that we're used to working with. So UV mapping is very much like taking a 3D box and making it flat so that you can paint on it and draw on it. Except we're dealing with more complex objects. But it's the same big principle. We're sort of the reverse of modeling. We're taking 3D and trying to turn it into 2D. Does that make sense a little bit? Okay, and you guys have an art project that you're working on where you're taking paper and you're making a 3D object out of it. Right? You know what I'm talking about? It's basically the same idea, just reverse. So let's take a look at UV mapping and how it works. Now, in terms of UV mapping, it's kind of like mapping in our world, which is why I think the terminology is kind of the same. So let's take a look at maps in our world and how they work. Now, in our world, we have maps that help us find things. So let's say, for example, I say to you, hey, can you come visit me in my summer home in Attu, Alaska? And you say, awesome, okay, how do I find you drinking lemonade on your porch in Attu, Alaska? I say, well, I live in Earl Cove. So you say, okay, well, how do I find that? And I say, well, if you go to the island of Attu, and you see it looks kind of like an elephant. If you fly up over his head to the first wrinkle in the back of his neck, that's where Earl Cove is. So if you look at that and you see an elephant, you guys see an elephant? No. You see the trunk, see he's yelling, and that's his eye? No. Okay, an amoeba elephant. Okay, well, suffice it to say that explains my point. A, if you can fly, and B, you think that looks like an elephant, you might be able to find my house. But if I tell you C2, you know exactly what I'm talking about. I am taking an ambiguous analog form and constructing a digital means of figuring out where you are on the surface of the island of Attu. These coordinates give me a precise location, because UV mapping is very much responsible for two things. Help you find your way to where you are on the surface, and it has to make sense. It has to have a commonality to the understanding of where I am. And if you know letters and numbers, you can find anything. Does that make sense? Because I've got a grid to help me find the location on the surface of something. Now, when it comes to maps, this works great. All right. This is a relatively flat area. My apologies to Chris Columbus. But what if you're dealing with something more complicated, with something a little bit more curvature, more detail? Well, the Earth is an extremely complex curved surface, yet we can find any position on the surface of the Earth as well, using the same concept, except we're using lines of longitude and latitude. But it's the same idea. It gives us a grid pattern, some coordinates, so that we can figure out where on the surface of this object you are, because that's what it's got to do. Precision, the accuracy, and again, the mutual understanding. Anybody can come take a look at the globe and figure out where they are if they know the coordinates of longitude and latitude. Does that make sense? Hell yeah? Oh, yeah. Okay, where am I? And everybody gets it. So, nice when you're working with a globe, but here's where the problem comes in. With a complex 3D surface like the globe, I can't see all sides at one time. I can only see one side or the other. So how do I see what's going on other sides of something if I'm trying to chart a path to somewhere? And in terms of globes, yeah, they're really cool, but I can't really put it in my pocket, right? If I'm trying to turn it into something flat so that I can see all sides of it at once, and or be able to roll it up and put it into my pocket, or fold it up and put it in my pocket, I need a different design. And that's where you might see a map like this. You guys ever seen a map like this before? Yeah. Okay, great. So here's a map of the Earth. And it's basically the Earth, a complex curved surface, laid out flat. So I can see all sides of the Earth at one time, right? So I can figure out where I am and where I'm going. And it's got coordinates of longitude and latitude to help me find my way. And again, the two most important things about a map is the accuracy at which the map is created and the fact that it's easy to understand. Does that make sense? Hell yeah? Okay, because if I'm trying to go from one point to another and I need to know exactly what these distances are, or I could end up adrift. I can run out of fuel and be stuck in the middle of the ocean. Does that make sense? Hell yeah? Okay, so accuracy is critically important. So if I'm trying to show the globe laid out flat, I'm going to have to put some little cuts in my surface, because you can't take 3D and show it as 2D. I mean, I could take a sphere and squash it flat and then it's a circle, but I can't see both sides then. Does that make sense? So I'm going to have to take a sphere, put some cuts in it in strategic locations so I can lay it out flat. Think of it like peeling an orange, right? In order to lay that thing out flat. Now, something to think about. Where are the little cuts that I put in my map of the Earth? Anybody? It's over the ocean, right? Do you think it's an accident that it's over the ocean? No, not at all. I put the cuts over the ocean because the ocean is just blue, right? It's just blue. I can put a cut there and it's not going to be a big deal. Because what this is, and we're going to talk about this a little bit later, is a seam. It's a seam. Where there's a cut, you will see a seam. So I put it over the ocean because this is just blue. It's not a really big deal. If I have to cut through a landmass, that could alter or distort the distances that we need to have 100% accuracy on in order to find my way. Does that make sense? Yeah. Okay. So as a result, the cuts are in the water. Now, if this was a topographic map of the bottom of the ocean, where I'm trying to plot all the trenches and so forth, well, in that case, I might put the seams over the land masses, because what I'm really concerned with is what's going on underwater. If I'm making maps perhaps for oil drilling or submarines or something like that, I need to know what's going on the bottom. So I need a different kind of map, and therefore my seams will be elsewhere placed strategically so that I can get that map to do what I need it to do. Does that make sense? Hell yeah? Okay, good. Let me keep checking. Make sure everybody's on board. Let me see my digital friends. How are we doing? Good? All right, because I got to check everybody periodically. Okay. So let's take a look at UV mapping and how this pertains to modeling. So on the left, we have a complex 3D model. On the right, we have that model laid out flat. This will enable us to create textures. And you can see each part of my model is laid out flat over here. And what happens is we create these things, which are called UV shells. Each UV shell is responsible for putting texture on the geometry. Again, if you look at my chest and you look at the UV shell of my chest, you can see the coordinates on the UV shell match the coordinates on my polygon geometry, and that's what allows for the accurate placement of texture. It's almost like paint by numbers. Where I paint here is going to show up there. Does that make sense? Okay. And again, this is called a UV shell. And basically what it is it's taking a complex 3D object and trying to lay it out flat so that we can paint textures for it, or create normal maps for it, or displacement maps for it, or transparency maps for it. There's a great number of things that can be accomplished through the use of good UV layout, and it's critically important to the process in general. Now, let's take a look at some UV mapping ideas
before we delve into it. All right. Let me just resize Maya so I've got all my tools and everything fits on the screen. Okay. Now, polygon geometry has a number of different components. We talked about vertices, we talked about edges, we talked about faces. These are all components that affect polygon geometry in terms of modeling. We also talked about components of polygon geometry that affect lighting. We discussed the normals, okay? Now, there are other components of a polygon object, and these help us figure out coordinate space. And I'm going to hide my grid just for ease of demonstration here. Now, in terms of coordinate space, if we hold down the right mouse button, we see the vertices, we see the edges, and we see the faces, right? And these are the components we're used to working with. Vertices are points in space that define shape. If you move the vertice, you change the shape of the object. Well, we also have a coordinate or a component called the UV. And if you hold down the right mouse button, you will see the UVs. And UVs are points in space. They occupy the exact same area as the vertices, but they have a totally different job. They tell you where you are. That's all they are. They're markers. Where am I on the surface of this geometry? So you can select UVs, right? But they don't move. Again, they just tell you where you are. All right? Now, in terms of UVs, every piece of polygon geometry has a UV layout. As soon as you create a piece of polygon geometry, I create this sphere. It has a UV shell layout by default. However, typically, the default UV layout is very, very poor because Maya doesn't care about texturing, so it doesn't really work very hard at it. So what ends up happening is we usually have to reorganize it. A, so that it maintains accuracy, and B, mutual understanding. The difference is the mutual understanding is not between you and me. The mutual understanding is between you and Maya. Because you and Maya have to understand where those UV shells are so that you can put the textures in the right locations in order to see texture on the geometry. So it's, again, you and Maya working as a team and both understanding what you're looking at. Now, in terms of seeing your UV layout, where you want to go to do that is go to Windows, General Editors, and, oh, no, I'm sorry. They broke it out on this other menu set. I got to stretch out my Maya. There we go. If you, it used to be under Windows. If you go to your main menu items, you'll see UV is its own little category. If you go to UV and select UV Editor, that actually opens up the UV Editor. And this is a fun little window which does all kinds of cool stuff. And let me make it a little smaller though, because it's enormous here. My goodness, this thing is like Texas. What is going on? It just keeps going. Have you guys ever seen a window that big? I'm going to have to come over here. Yeah, this is crazy. What the heck was going on in there, huh? It's huge. All right, that's a little bit better. All right, now, in terms of the UV editor, what you're going to notice is the UV editor is an orthographic window, just like any other window in Maya. So in terms of its navigation, you can track or dolly or zoom in or out, but obviously no tumble. It's got its own little menu items within this window, and these are where the tools for UV mapping are housed. So you're going to be looking for them in here amongst other places. Now, right off the bat, you'll see I've got sort of this grid configuration in here, and then mountains and mountains of empty space out here. And what I'd like you to realize is when it comes to UV mapping and the creation of UV shells, We're really concentrating on this area in here, and specifically for this class, right here, this quadrant. This is called the 0 to 1 space. It starts at 0 at the origin and 1 at the end. And this is the area, this particular quadrant, by default, this is where Maya goes to find diffuse color information to place on the geometry when we want to place it in a specific location. Now, this area out here, the workspace, this is where we're going to work on whatever it is we're creating. And the way I'd like you to think of it is, imagine that all of this is your desktop, and this is where we're working on stuff. We're cutting stuff, we're gluing stuff, we're moving it around. But when we're all done, we put it inside this 0 to 1 space, and it's like a frame. I'm framing my picture, my artwork. When it's all done, it's going to go right here and hang on my refrigerator. Does that make sense? Oh, yeah. Thank you for playing. So again, out here, there's a lot of space because sometimes you need a lot of space to work. But ultimately, it all gets framed right here in my 0 to 1 space in the UV editor. Now, we're in the UV editor right now and we don't see anything at all. Absolutely nothing. But I do have a polygon object. And that's because if you don't select the object, you can't see its UVs because UV layout is object specific. So if I select the object, now all of a sudden, I see that object's UV layout. So this is the shell for this object. So Maya thinks if I took a sphere and laid it out flat, it would look just like this. Yeah, wacky, right? Now, in terms of what's going on here, this is a flat map that represents this object. And we've only been talking about UVs for about 20 minutes or so, right? Not all that long, 23 minutes of UVs. But how do you know, how would you suspect that this is not an accurate layout of that, just by looking at it? What doesn't look right?
All the faces are compressed into similar sides.
Right, if you look at these are supposed to be the faces, right? So these faces here represent those faces there. These faces are almost all perfect squares, right? We get some triangles at the end, but a whole bunch of perfect squares. So if this face right here represents that face right there, are these squares, are these perfect squares on my sphere? No, they're not. What shapes am I seeing a lot of on my sphere? Rectangles. So if I have a square of information and I'm trying to fit it into a rectangle, what am I going to have to do to make it fit? Will a square fit into a rectangle? Yeah. It can, but I'm going to have to stretch it to make it fit. Does that make sense? Because a square is too small. So if I have a picture that's a square and I'm trying to fit it into a frame that's a rectangle, I'm going to have to stretch that picture to make it fit. Will that affect the picture? Yes, it will distort it. So when we're talking about inaccurate layout of UVs, what we see is distortion in our textures, stretching. Things don't look right. Does that make sense? That's why UV mapping is so important in terms of the accuracy. I have to do a good job of laying out my UVs or my textures will look terrible. Does that make sense a little bit? Hell yeah? Ooh, that was a very quiet hell yeah. Hell yeah? There we go. That's a little bit better. All right. So obviously this is not such a great layout. And this is pretty straightforward, right? If I'm looking at a sphere, you know, yeah, I can tell that's not a very good layout. But here's a better question for you, or another question for you that can get into that, because we're talking about accuracy first, right? So obviously accuracy is not so great. Mutual understanding, okay? You and Maya both understanding where you are on the surface. Let's say I want to create a texture for this sphere, a texture of the earth and put it on there, okay? And we'll say I'm doing a news show, right? I want to have a globe spinning behind me, because nothing says news like a globe spinning behind you while you're talking. So if I want to put a texture of the earth on this sphere, and I want North America to be right up here, because that's where I envision North America to be. Where is that? Over here. How do I find that? Is there some way for me to figure that out? Any thoughts? What?
If you were scanning that section of the object.
Scan that section. Now I could try to figure out where the heck I am, select the faces. Let's take a look.
Let's say, for example, I want to put put North America right up here, because this is kind of where we imagine North America would be. And I select the UVs, right? There's Florida right there. Let's see where that is on my grid. There it is. That's where those coordinates are.
I would have never guessed that's where that is. Does that make sense? And that's what it would have to be, is that guess. I have no idea where the heck I am on the surface of the earth when I look at this. So mutual understanding? No. Accuracy? No. So this needs to be remapped. I need to map it again and make it more accurate. It needs to be more accurate, and it needs to make more sense, so I know where the heck I am on the surface. It's not working like this for me. Does that make sense? Okay, so we don't destroy UVs, we just reorganize them so that they make more sense and more accurate.
All right, so when we're looking at this sphere, this is a pretty simple example. This is very straightforward. But what if you're looking at something a lot more complex, right? Like a 2 million polygon Optimus Prime. You're not sure what's good UV layout and what's bad. So we have a way of testing. We have a way of finding out how good or bad UV layout is. All right? Now, what we use is a test pattern. We can check it by putting a checker pattern on our object. That way we can tell when we have good layout or bad layout. Because a checker pattern is composed of happy little squares. They're all the same size, they all look nice and neat, and there's no distortion. So what we can do is assign a practice texture to our geometry, and it will tell us, do I have good layout or bad layout? And if I have bad layout, I can remap it and look at the texture. And once I see happy little squares, I know I've reorganized it well. Now, to give you an idea of good and bad, you'll notice all of these squares, and it doesn't matter which piece of the object you're on, by the way. You notice that these squares on the leg are the same as the squares on the chest, same size. That's a function of resolution. We're going to talk about that too. But these squares are all the same size, right? All happy little squares. No distortion. That's going to yield a good texture. Does that make sense? Now, if you look right here in the arm, do you see right up there? There's some distortion going on there. I don't have perfect squares in this little area here. Very good squares here, here, here. Again, different pieces, but they all have the same size squares, and they're all looking good. But when I go to the shoulder here, there's a little distortion going on. And I can see it because the squares are not perfect, happy little squares. They're distorted somewhat. They're stretched. Does that make sense? Okay. Now, something very important to understand is when it comes to laying out UVs, you're not always going to have perfect UV layout. There's going to be some distortion here or there. It's unavoidable. However, what you have to take a look at is, will this affect me a lot or not so much? So for example, when you look at my character, you'll notice on my chest, I have this really cool Hawaiian pattern. It's dancing monkeys, in case you were curious. But on my arm, it's just orange. So when it comes to my UV layout, the fact that this looks as good as possible is good because I have a pattern on there. When you've got a pattern on a texture, it will be very obvious if there's distortion because the pattern will be distorted. However, on my arm, where there is a little bit of distortion, my arms are only orange. So there's no pattern there, less likely to cause an issue. Does that make sense? It's just about being smart about where distortion is acceptable and where it is not. Let me check all my digital friends. You guys have any friends? Any questions for me? I could actually, if you have any friends for me, that would be good too. I'm tragically low on those as well. No? Okay. All right. UVs are pretty crazy. Don't be afraid to ask me questions. All right. So, again, our test for determining how well our UVs are laid out is we assign a test material to our object. These are the steps for assigning a test pattern texture to our geometry to determine accuracy. And this is something we will do many, many times. So, step one, I'm going to create a new material. So I go to the Hypershade, and this is all stuff we've done before. You've just not put it together in this order. Window, Rendering Editors, Hypershade. All right, once we're in the Hypershade, we make a new material. And we only work with Lamberts in this class. So I go to Lambert, and I click on it. And it makes a new Lambert material. All right, I'm going to name that material. Always a great idea to name as you go because it gets chaotic if you don't. Checker material. All right. Step two, if I was going to be coloring this special new geometry, I would click on the color channel, which would open up the color history, and I would pick whatever color I want. But I'm not coloring the geometry, purple, green, or what have you. I'm going to assign a texture to it, right? So instead of clicking on the little color swatch here, I'm going to go to the little checker box at the end of the color channel. And the way I'd like you to think of these checker boxes, think of them like a power strip, right? That you would plug many devices into. You want to run your computer, your microwave, your vacuum cleaner. You're going to plug a bunch of stuff in. So each one of these checker boxes is a plug that you can plug stuff into. So what I'm going to do is I'm going to go to my color channel, go to the end to the checker box, Gesundheit, and click on the checker box. And that's going to launch my Create Render Node window. Now, there are many nodes in here that are a lot of fun, but the one we are going to play with right now, the next step, is we are going to click on the checker material. So I click on this node, and it basically assigns a checker pattern to my material that I've just created. And if you look in the Hypershade, you can see the material and you can see the checker pattern on it. Now, something, just me to you advice, when it comes to UV layout, you notice your UV shells are white in color. This is the shell. The little lines are the shell. They're white in color. What I recommend very highly is when you apply a checker pattern to your material, it starts out by default black and white. Create another color for the white color because it's very hard to see white on white because it's almost identical. So just me to you advice, click on the color and just make it something else. You can make it any color you want, but I recommend it highly because it's way easier to see the shells against a different color. All right. So now I've created this new checker material. So the next step is I need to assign this material to my object because right now my object is made of Lambert number 1, the default material in Maya. So if I want it to be made of this, I can, there's several ways to do it, but I can hold down the middle mouse button, drag it to the material or to the object and let go. Gesundheit. I can also select the object, and in the Hypershade, hold down the right mouse button, assign material to selection. Right? We did both of those. Now, at this point, I still don't see my checker pattern on there. Now, you guys remember we pressed 4 for wireframe, right? We pressed 5 for shaded mode. Well, if we press 6, we get texture mode. So if you press 6, you see your geometry with whatever texture happens to be on it. So I can see the checker pattern on here now. But if I look at my checker pattern, right, in my UV editor, I see perfect, happy little squares. But when I look at my geometry, what shapes do I see? Rectangles. So that's telling me I don't have a good layout. I'm seeing distortion because my squares are being stretched into rectangles. Does that make sense? And if you look at the top, catastrophe. Obviously, those are not squares either. Does that make sense? So, to test our geometry, regardless of its shape, we apply this checker material. And that tells us how well our UVs are laid out. And if they're bad, we fix them. Does that make sense? Get a hell yeah on the material application? Okay, good. So that's the first thing we do, is we apply the material. Then we actually go into the process of UV mapping. Let's talk about that. Now, there's a couple of tools we use for UV mapping. Actually, there's quite a few. I'm only going to show you 2 because, to be honest with you, with all the UV mapping I have ever done, I've really only used these tools, these 2, the overwhelming majority of the time. I'd say 99% of the time, if not more, I use these 2 tools. You've got to learn how to use these. Now, how many of you guys have ever taken a picture? Come on, you've taken a picture. If you have ever taken a picture, what you have done is taken a 3D concept, like what we call reality, and we turned it into 2D by making it a picture, because we can take that picture and print it out. And we've just taken 3D and turned it into 2D. Does that make sense? Okay. UV mapping, one of the tools we use, works very much like a camera. We are literally taking pictures of objects because it creates a 2D version of that object. So if I wanted to create an image of my head and lay it out very accurately, I would take a picture of the front of my head, I would take a picture of the side of my head, I would take a picture of the other side of my head, I would take a picture of the back of my head, and I would take a picture of the top of my head. And I would try to attach these to each other. Does that make sense? That would be an accurate layout in terms of the spatial relationships of the surface of my head. And I could do that by taking a series of pictures. Does that make sense? So one of the tools that we use is called the planar mapping tool. And the planar mapping tool is kind of like a camera. It just takes pictures of whatever it is you're trying to map. Now, how many of you guys have ever had an MRI? Really? Ooh, not many in this class. Usually there's quite a few. It's scary. I don't know. If you've never had an MRI, lucky you. If you've had an MRI, you have my sympathies, because I've been through that a couple times. It is not fun. Not fun. But basically what happens is they take your body and they lay you down on a little bed, and they shove you into this tube. And the tube is not very much bigger than you are. And this tube has a series of very powerful magnets in it. And what those magnets do is they slowly move around your body. And these magnets are so strong, they literally pull on the molecules of your being. And then after the magnets pass by, they let go, and the molecules move back into place. And the machine measures the movement that takes place, and it generates 2D images of what you look like on the inside. It is a crazy process and super noisy and very nerve-wracking. But it is basically like a scanner, right? We take images and we scan them and create images with them, except this scanner scans in a cylindrical pattern. It goes around you and it scans you and it generates an image. Well, there's another tool that we UV map with called the cylindrical mapping tool, which we use predominantly with cylindrical shaped objects. And that allows us to take pictures of a complex 3D object that is cylindrical in shape and generate a 2D image. So it's kind of like that as well in terms of its behavior. You could imagine this like a shell. Now, in terms of what these two tools look like, this is the planar mapping tool and this is the cylindrical mapping tool. And as you would imagine, the planar mapping tool is used primarily for planar objects, things that are flat, but you can use it on curved things as well. And you'll see it has a series of manipulators that you can play with to change the size and the orientation of the tool. And it's got this little red T in the corner. And this is very important because you can click on that and actually change the angle that the plane is on if you need to take a picture on a different axis. So this is sort of the thing that frees it up to be manipulated like that using a rotational tool. The cylindrical mapping tool works the same way. It scans in a cylinder and it generates an image. It's got manipulators on it also that help us to change the shape of the tool. And it's got the little red T that we can click on to change its orientation to make sure it's matching. Now, in terms of matching orientation, this person is lying down. Would it do me any good to scan them around this direction? No, they're lying down, right? So I need to scan in this direction. So when you're scanning an object, it is very important when you're using the cylindrical mapping tool that you scan in the same axis that the object is on. So in this instance, the object is standing up and down. So you'll notice that my cylindrical mapping tool is up and down so that I can match the shape that I'm looking at. All right. Well, I got some hell yeahs in there. Oh, thank you. All right. Sorry. I got to stop smoking cigars before I come to work. I'm just kidding. I don't smoke cigars. I wish I had a good excuse like that. All right. So here we go. Let's take a look at this mapping process and how it works. All right. So you know I've got a fun little activity for us so that we can do this. Right? Let's practice UV mapping. So I'm going to set my project to my activity files. And I'm going to open up my UV mapping activity. And it should be at the bottom alphabetically. Okay. Yep, UV mapping activity. Make sure you got that guy. Okay. Now, when you first open up this scene, you'll see three pieces of geometry, three very simple ones: a plane, a cube, and a cylinder. And these three objects need to have their UVs remapped. Now, who can tell me, what window do I go to look at my UV editor? The UV window, absolutely, UV editor. Go to UV and choose UV editor. All right. Now, when I get to the UV editor, again, it navigates like an orthographic camera, so you got to move around in there. I don't see anything. Why is that? I didn't select the object. Remember, to see an object's UV layout, you have to select it. So I'm going to select the geometry plane. So this is what the plane looks like. And when I select it, that's what Maya thinks its UV layout looks like. All right. So does that look accurate to you? Does that, if you took that plane and laid it out flat,
P.S. It is flat. Would it look like that?
Absolutely.
Yeah, absolutely. No, there's definitely a bad layout. I can tell just by looking at that layout, I know it's not good, right? Let me check with my digital friends. You guys on board with that? Yeah, maybe. Hell yeah, there we go. All right, so now, but we can test this, right? So I don't have to eyeball it. It's not just up to me. We can apply a test pattern to it, and that will confirm good or bad layout. Does that make sense? And it's super easy. Who can tell me the steps for the creation of a new material and the application of the test texture pattern so that we can check this and just confirm that this is not a good layout? Open your Hypershade, Windows, Rendering Editor's Hypershade. Create a new Lambert, right? So I create a new Lambert. All right. So I got my new Lambert. I've created it. And remember, I like to name stuff as I go so it doesn't get away from me. And this checker material I can use in this scene on all of my objects. So good idea to name it. So what's the next step? What's that?
Put the checker on.
I got to put the checker on, right? I got to apply it. So how do I do that? Click on the little checkbox, right? So I go to the end of the color channel, I go to the checkbox and I click on it. And that opens up my Create Render Node window. Which of these many lovely nodes do I want? The one called checker, right? So it's the second one down. I click on it. And again, between you and me, I like to color the white to something else because it's just easier to see. So I'll click on the white material and I'll make it green this time. Okay. So I've got this new material. And if I look at my Hypershade, I can see it. It's right there. How do I apply it to my geometry plane? Middle mouse button, drag and drop is one way. I can select it and right mouse over the material, assign to select it. But I still don't see my checker pattern. Got to press 6. So I press 6, boom, I can see it now. All right. So this UV layout, I see my texture applied, nice happy little squares. Do I see happy squares over here? No, not at all, right? This looks like a pair of pants or a shirt from an 80s rock band, right? That's not going to work. So obviously, layout is bad. Does that make sense? This confirms poor layout. So now I go through the steps of UV mapping to try to realign them. So these are the steps to UV map an object, okay? Now, this piece of geometry is a plane, right? A flat plane. So odds are pretty good you're going to use which tool, do you think? The flat one, the planar mapping tool, because it's a plane. So what I'm going to do, these are the steps for mapping a piece of geometry. Select the face or faces you wish to map. So there's only one face, but I select it. All right. So number 1, select the face or faces you wish to map. Number 2, under the menu set UV, go to the planar mapping tool. And of the utmost importance, we must go to the options box because it is very, very important we tell Maya what axis to take the picture on. This is very, very important. Now, in terms of this face, if I want to take a picture of this face and lay it out accurately, what axis should I take the picture on?
Why?
Y-axis? Anybody have another axis they want to choose? You guys think it's Y? Okay. Well, the answer is it is Y. Because if I'm looking at this piece of geometry, if I'm looking down on it, that's going to give me the most accurate look at it. If I take a picture on this axis, which is Z, I don't really see very clearly the surface of this object. If I look at X, I don't really see the surface of this object. But if I look at Y, oh yeah, I can see that object quite well. So what I want to make sure is that when I've got my UV mapping tool out, the planar mapping tool, I want to choose the correct axis. I'm going to choose the wrong one just so you can see what happens. I'm going to choose X. Let's say I thought that was the right one. I hit apply. Do I see happy squares there? No. So I know it's not the right axis because I'm not seeing happy squares. So instead, I'm going to choose the Y axis and apply. Oh, I see happy squares. So if I got happy squares in here and I see happy squares out here, I've got a good quality layout. Does that make sense? Thank you for playing. All right, now, in terms of the manipulation of this tool, as I promised you, there are manipulators on here that I can use to change the shape. Oh yeah, you like that? All kinds of fun stuff that I can do to manipulate it. And remember that little red T? That's right over here. If I click on that, it creates something that looks like the extrude tool, and I can click on the circle part of it, and that will allow me to angle the camera if I need to map at an angle if necessary. But the good news is it's a flat object. I took the picture on a flat y-axis. I'm all good. And you'll see over here, watch my UV shell change. It goes from this weird pointy arrow thing. When I map it, it makes a nice happy square. And as I create my shells, I drag them out of the 0 to 1 space into the workspace. So this is my UV shell. And you can see, again, I've got happy squares here, so that's all good. Now, in terms of moving UV shells, this is very important. If I go to UV mode, and you have to be in UV mode to move a shell, because a shell is composed of UVs, all right? Actually, you can go to face mode too and grab it, or edge, but you got to get all of them. But something very important for you to realize about UVs is you can grab one UV, and then using your move tool, you can move it. But look at what it does to your layout. Yeah, it's crazy, right? I'm distorting my texture because the UV shell no longer accurately represents the physical geometry. Does that make sense? So you don't want to move just one UV. You want to make sure if you move a shell, you grab all the UVs and move them together, because that maintains the shape and proportion of your shell. Does that make sense? Hell yeah? Awesome. All right, so there's our first shell. Let's try this again. This time, we're going to do it with a cube. It's more complicated, but the good news is a cube is a series of planes. So, what's the first thing I need to do? I heard somebody say it. The very first step. I'm going to go to the hypershade, because in terms of this cube, is it good layout or bad layout? It's horrible, but I don't know that yet, right? Let's take a look at the UV editor. I'm going to open up my UV editor, right? And I'm going to select my cube. So Maya thinks if I took this cube and laid it out flat, it would look like that. So you and I, just looking at that, you and I know that's not good layout. That's obviously poor layout. But again, we always test it. And we test it by applying this checker pattern to it, right? This is this is the catch-all. This will prove good or bad layout. So again, the steps for applying the material are: number one, you go to the hypershade. Window Rendering Editor's hypershade. Now the good news is I still have this material here, this checker pattern. I can use it on as many objects as I want. So I don't have to make a new material and plug in the checker, but it would be the same process again. So what I need to do now, we'll do it again just because it's great to repeat things. So I'm going to make a new material. Click Lambert to make a new material. This is going to be my new checker material. All right. Now, in terms of my checker material, how do I apply the checker pattern to it? Who can tell me? Go ahead. Go to the color channel, and then do what? Go all the way to the end of the little checker box. It creates, there it opens up the Create Render Node window. Which node do I want? The checker one, number 2. So I click on that. And again, I like to change the color from white to something else. We'll make it yellow this time. All right. So now when I go back to my Hypershade, there's my new checker material. How do I apply it to my cube? What's that? Select the object. And then over the material in the Hypershade, right mouse button, assign to selection, or I could middle mouse button, drag and drop, both of which work. Now, do I see happy little squares there? When I look in the UV editor, I see happy squares, but when I look in here, I don't. So my UV layout, is it good or is it bad? Bad. So I need to fix it. This is a cube. It is made of a series of planes. Which tool do you think I'll use? Planar mapping tool, right? Makes sense. So let's start using the planar mapping tool. The next step is you select the face or faces you wish to map. So first I'm going to grab this face on top. Okay. Now, if I want to take a picture of the top of this cube, what axis do I need to be in to take that picture? Y-axis, right? I'm looking down at it. Makes sense. So I go to my UV mapping tool. I go to the planar mapping tool. And I set it for Y. It's actually still on there. And I hit apply. And it creates a UV shell. And see, it looks like happy little squares, so I know I did a good job. It looks right. So as I create a shell, I drag it out of the 0 to 1. All right, and that leaves me with that checker pattern. There's still some shells in here, so I know I still got work to do. So now let's grab another one. What axis do I want to take a picture of that face on? Z-axis, right? Because I'm looking at the front of this cube. So if I want to get a picture of the front of this cube, I need to take that picture on the Z-axis, right? So I need to get this face, so I'm going to have to take it from this angle, right down the Z. If I take a picture on the X-axis, I'm not getting a good look at that face. If I take it on Y, I'm not getting it. But if I'm looking right at Z, that's a perfect view of that face. So, again, UV, planar mapping tool, and this time I'm going to choose the Z-axis and hit project. And as long as I keep seeing happy little squares, I know I'm doing the right thing. So then I'm going to take this one and drag it out of the 0 to 1. All right, let's do another one. If I'm going to take a picture of this particular face, right, what axis am I going to take the picture on? X-axis, absolutely. Because again, if I look straight down this axis, this is where I have the best view of that cube. Y is not a good view of it. Z is not a good view of it. It's got to be X. So, planar mapping tool, X-axis, apply, and again I get a nice checker pattern, and I've created another little square in here, and I'll drag that out of the 0 to 1. Okay? Now, here's where it starts to get a little bit tricky. If I want to take a picture of this axis, if this face, what axis do I want to take the picture on? I want to get a picture of right here. Go ahead. It's the x-axis, right? Now, you would think, though, that since I'm on this side, it would be negative x, right? Because we know the arrow points to the positive side. So looking at this, you would say, okay, negative x. But when I look at my planar mapping tool, there is no negative x option. So I just leave it at x, and I hit apply. And again, I get happy little squares. I take that shell that I just created and drag it out of the 0 to 1. Okay? And again, I like to pull my shells out, because if you just keep mapping, those shells end up on top of each other. It's just one after another, and they just get stacked up on top of each other. And we're going to talk about how to align them shortly. All right? If I want a picture of this face, what axis should I take this picture in? Z, absolutely. I'm looking at the back of this object. I'm looking down the Z axis. So if I want to get a picture of this face, I'm going to choose the Z axis. And again, I create another happy square. And this all looks good, right? I see that there's still some stuff in my UV editor. That's because this face hasn't been mapped yet. So, what axis do I take a picture on to get a picture of this particular face? This is the y-axis, absolutely. So, if I want to get a picture of this, I need to use my y-axis. Again, I get a nice little picture there. And I take my shell and I drag it out into the 0 to 1. So now, when I look at my object, it's all happy squares. Now, oh yes, go ahead. You could do that, but what I would caution you against that is because if you map X on both of those at the same time, they're basically, the shells would be on top of each other in the 0 to 1. Does that make sense? You would end up with two shells on top of each other, and you wouldn't necessarily know they were on top of each other because they would be exactly perfectly stacked on top of each other. Does that make sense? And just for beginners, I recommend not doing that. As you get more advanced and you're more aware of what's going on, yeah, you can do stuff like that, absolutely. But it's something you have to be very conscious of. Does that make sense? Okay, so just for the ease of use, it's a little bit easier. Now, you guys remember when we were talking about the space, right? This is like your desk. This is where you do all your artwork. You're cutting, you're gluing, you're stapling, whatever you're going to do, right? But when we're all done, we fit everything into this perfect little frame, right? We talked about that. So in terms of getting these shells in here, this is a square in shape. So what I'm going to do is I'm going to take my UV shells and I'm going to move them close to each other, as close as I can get. But you'll notice I'm not overlapping them. I want to make sure they're super close to each other, but not overlapping. I'm grabbing these shells and moving them near to each other, but not overlapping. And what I'm doing is I'm preparing them to go back into the 0 to 1 space, because that's where they're going to go once I get them all in here. Now, once I got them pretty tightly packed, I'm going to grab everybody and I'm going to shrink it down and fit it into this 0 to 1 space as tightly as I can. I want to use up as much space as I can. But I don't want my shells, any of it, to be hanging out of the 0 to 1. Everything needs to fit neatly within the 0 to 1. Does that make sense? Okay, now, something I want to point out in terms of these shells. You'll notice that the bigger my shells are, the smaller the checker pattern is. And when I shrink this UV shells, when I shrink them down and try to get them into the 0 to 1, do you see how the squares get bigger? That's okay. That's fine. That's not a big deal. What's important is, regardless of how big these shells are, they need to stay the same size relative to each other, because the cube is composed of 6 faces that are the exact same size. So if I take one of these and make it smaller than the others, that's going to change the resolution of my texture. So what I want to make sure of is that when I change the size of my shells, when they're all looking good like I like them, and I want to get them back into here because that's the last thing I do, I move them all together and put them in here. All right? Now they all fit into the 0 to 1 very nicely and neatly. And you might say, well, wait a minute, the squares on the cube are bigger than the squares on the plane. That's fine. What I want is for every face on the object to have the same size squares on the same object. I'm not comparing the plane to the cube. I compare the cube to the cube. Does that make sense? Okay, that's important. So make sure you're doing that. All right, so these guys are done. Let's take a look at cylinder. Same thing. UV layout, not very good. So what we're going to have to do is remap it, right? But the first thing we do is test it to make sure. I mean, I'm pretty sure that's bad UV layout, but we always confirm by applying the texture, the checker pattern. Who can tell me how we do it? What's the steps? Go to the Hypershade, Windows, Rendering Editor, Hypershade. I'm going to make a new material. So I make another Lambert, right? And then I'm going to call this my new checker material, right? How do I apply the checker to it? I go to the color channel, I go to the checker box next to it, click on it, it opens up the Create Render node. Which node do I want? The checker one. So I click on checker. Again, change the white to something else. I recommend that highly. Let's do light blue this time. All right. Now, how do I apply the material to my object? Drag it on there with the middle mouse button. I can also select the object and hold down the right mouse button over the material. Assign to selection. All right. Now, this confirms for me that layout is bad, because I don't see happy squares. Now, here's where it gets interesting. This is a cylinder. It's a little bit more complicated than a cube, but it does have planes on it. If you look at the cylinder, this is a circle, but it's a plane. It's a flat plane. It's just a circle shape. Does that make sense? So I can grab the faces on the end of my cylinder and take a picture of them, right? Which tool do you think I would use? The cylindrical mapping tool or the planar mapping tool? planar because it's a plane. Even though it is a circle, it's a plane. So I go to UV, planar mapping tool, and which axis do I want to take the picture on? Take a look over here. All right, if I want to get a picture of this face, I'm looking right down the x-axis. So I want to make sure that I choose the x-axis and I hit project. It takes a picture and I'm rewarded with happy little squares, which again is my goal. As I make my shell, I drag it out of my 0 to 1. So I got that. Let's do the other one. Grab the faces. Okay. What axis do I take this picture on? X. Yep, X again. Right? That's the axis that I'm looking right down. UV, planar mapping. Choose X. Take the picture. It makes another little circle. That's the other end of my cylinder. So now, when I look at this, I've got happy squares on there, happy squares on there, but the middle is not good. So here's where I have to map the middle of my object. Now I could select my faces one at a time. That would be kind of slow. But I could do a marquee selection and grab all the faces all the way around at one time. Right? That's going to get me everybody at once. Now, in the past, we've been dealing mostly with planes, and that's why we use the planar mapping tool. This object is definitely a cylinder. So here's an instance where we're going to use the cylindrical mapping tool. So again, we go to UV just like we did before, and we choose the cylindrical mapping tool, which is just above the planar. And the tool appears. Now, let me make this a little bit bigger so you can see it. Do I have happy little squares? No, definitely not. And if you look at my UV layout, it kind of, in here, it kind of looks like an apple core or something, right? So I don't have a good layout. And that's because my cylinder is sort of lying down, as it were. It goes around this way. But my tool is mapping this way. Does that make sense? The tool does not match the orientation of the geometry. So what I'm going to have to do is click this little red T, which gives me the tool that looks kind of like the extrude tool with that big ring around it. I just made it bigger so it was easier to see. And I click the circle, which will give me the rotate capacity of the tool. And what I'm going to do is rotate the tool so that it's scanning on the same axis that the object is lying on. And if you look at my UV shell, watch my UV shell. It goes from this, which looks terrible, to what you would imagine a cylinder would look like if you took like a soup can and cut the ends off. Right? A big rectangle. That makes much more sense. And I can literally plug in 90 degrees in terms of the orientation of that tool to ensure I'm getting a better layout. Does that make sense? Okay, so I create the shell, drag that out of the 0 to 1. Now here's where it gets a little bit interesting again. If you look at my object, do the squares on the end, are they the same size as the squares on the side? No. So here I've got a problem of resolution not agreeing. Okay? The squares here are smaller than the squares here. On the same object and pieces of the same object, the squares need to be all the same. So I'm going to have to make an adjustment. So what we're saying is the proportion of this is not the same as the proportion of this. And to be honest with you, if you look at this object, doesn't that look you know, kind of like a soup can in terms of its shape. But if you look here, let's imagine I could cut this out and wrap it around this circle shape. This would be a can, but it wouldn't be a very tall can. It would be a very short can. It would be much more like a tuna fish can than a soup can. So I can see, just looking at these shells, they don't look like they match up like the real object does. And that's why when I look at the squares, they're different sizes. So what do I do? Well, I either need to make this shell bigger or smaller, or these shells bigger or smaller. So I'm going to deal with this one because there's just one of these. I grab it, and I'm going to use my scale tool. And watch what happens. When I make this thing get smaller, the squares get bigger. When I make this thing bigger, the squares get smaller. So what I'm doing is, I'll pick a square on one side of the object, and I'll try to make the shells on the other side match. You can see it's just a little bit too big. So I switch back to my scale tool, make it just a little bit smaller by making the shell bigger. And when those squares are more the same size, then I know I've matched the resolution. And all I'm doing here is scaling the shell to make it bigger or smaller, and I'm using my move tool to line up the squares a little bit so I can make sure that they're of similar size. Does that make sense? Okay, now, once the squares on the end are the same size as the squares on the middle, then I know the proportions are accurate. The resolution of the shells is the same, and I've got good layout. And if you look at it, now if I were to take this rectangle and cut it out and wrap it around this circle, that looks much more like the soup can that I imagine it would look like in 3D. So the squares are helping me confirm that which I already suspect in terms of the layout. And we also talked about the fact that once our shells are all done, they got to go back into the 0 to 1. So I'm going to tuck them in real close to each other and very careful not to overlap them. Right? And then I grab everybody, and now I'm going to scale them down and fit them into my 0 to 1. And again, they got to fit in there super tight, nothing hanging out on the end. Everybody's got to get in there and fit into that 0 to 1 space, nice and neat. And again, the squares on this object are bigger than the squares on this object, but that's okay. Those are two totally different objects. That doesn't make any difference. I just want to make sure that the squares of the same object are the same size. All right? All right, my online friends, how are you guys doing? I know that the UV mapping is a complicated process. I'm glad you are keeping up, but how is that going along for you guys? Seems reasonably good. Yes, go ahead.
So I didn't do anything different than you did, but my squares on the sides of the, like the round part of the cylinder are still off.
Well, something you have to take a look at with your shells is you have to make sure that the proportions are correct. So for example, the question is, why are my shells My squares not looking like squares, they're looking like rectangles. So let's take a look at our object and take a look at our shell. All right, and it'll actually be easier if I make it a little bit bigger. So you got more squares to see. But watch what happens when the proportions of this are incorrect. Do you see how they look stretched here? Because this is too tall relative to the real object. It's not that tall. You know, that would be like a Red Bull drink in terms of the shape of the container. Does that make sense? That's a very tall can. Subsequently, that's more like a tuna fish can, not very tall. Again, distortion. It's all about making this shell have the exact same proportions as this object. Think of it like I'm going to cut this out like a label and wrap it around this can. If it's the wrong size, the label's not going to fit. I'm either going to see parts of the can or the label is going to be too big and it's going to hang off the sides of the can. An accurate fit will result in happy squares. If you don't see squares, you don't have the right proportions. There are many tools we can use, but for right now, we're going to eyeball it. Does that make sense? Because I want you guys to get used to making adjustments in the 0 to 1 or out here in the workspace to get these happy squares to be accurate. You need to understand that relationship of physical manipulation of the shells to achieve accurate resolution. Does that make sense? Okay. So next class, we're going to talk about some more tools we can use. But make sure we get everything into the 0 to 1 when we're all done. All right? Now, is there anybody else who has any questions on this? Because I know there's a lot of steps. It's not overly fun. It is technical. But this is a critical part of the modeling process. Because as a modeler, you will be responsible for laying out the UVs. If you model polygon geometry, you will have to lay out the UVs. That is part of the job of the modeler. Typically, the modeler also does the texturing, but not always. There are instances where there's a specialist who does the textures. But the modeler is absolutely responsible for the UV layout. So if you are a polygon modeler, you will have to UV. And that's why this is so important, because you will do this for the rest of the time you are at Full Sail. You're going to have to learn to UV map. And it's not easy. But the good news is there's so much cool stuff you can do once you have UV mapped something. You can create textures for objects. You can create normal maps for objects. You can use amazing applications like ZBrush to create fantastic detail on your geometry. But you can't do any of that until you get a good UV layout. Without it, it's impossible. Bad UV layout not only yields poor texture application, but it also makes applications like ZBrush not function properly at all. So UV mapping becomes critically important, and that's why we go over it even in the very first modeling class you have. You will be UV mapping everything you model from here forward. So we need to learn this process and understand it. Again, it's meticulous, but at least it's repetitive. You know what I mean? If it was completely different every time, that would be a nightmare. We follow the steps, we do the mapping, and it's pretty straightforward. But what I'd like you to think about UV mapping is it's not necessarily ABC, you're done. It's an exploration, it's a process. It's almost like a riddle you have to solve, because every object will UV map differently. We use the same tools and techniques, but you've got to find the solution. And you know, you might completely UV map the object and go, you know what, this layout is terrible, and you might have to map it again. That's fine. You just grab the faces and start with the mapping again. You're just reorienting what you already have. Did you have a question?
Yeah, so for more like complicated objects, we would have to like UV map it piece by piece rather than the whole thing.
Absolutely. Some things you can map piece by piece. Some things you do the whole thing. For example, let's take a look at, incidentally, everybody's okay with this activity before I open up another file? Okay, I just wanted to make sure you guys had reasonable success with this activity because our skill check, we're going to be UV mapping something. So definitely want to make sure you guys understand this. But let's say, for example, let me do this. I'm going to set my project, because texture information is part of setting the project. If you don't set your project, your textures don't come through either. So again, many good things happen from setting your project. But let me set my project there, and then I'm going to go to File, Open Scene, and I'm going to grab my me. All right. So again, 4 is wireframe, 5 is shaded, 6 is texture mode, and you can see the models look so much cooler with the texture on them. What's that? Yes, they're the monkeys. Did you see them? They're dancing. But where the texture goes is based on your UV mapping. So let's say, for example, I'm going to open up my UV editor, and I'll grab my character. And you can see, here's all these shells in here. And let's look at the face. All right, they're the UV orientation to place the texture for my face. And if there's any kind of distortion on that, is that wild? So again, you want to lay out your UVs so that you're able to apply really cool textures to your geometry. And that's why it's such an important part of the process.
So when you're exporting your out to texture them, do you do it separately for like each object?
Oh, no, that's a good question. How do you actually paint it? Well, what happens is you select your objects. Here, let me just, I'll make it easier. Let me do this, hold on. I'm going to make it all gray just because it's easier to see without the texture in the background. When you want to paint your texture, what you do is you select your object, and you can see your UV shell layout in the 0 to 1. And then what you create is called a UV snapshot. And let me see where they put it now. There we go. It's under image now.
And what happens is, when you take a UV snapshot, you're basically taking a picture of this area, and it creates an image.
And then you take that image. Here, I'll do one for you. I'm gonna send it to my desktop just because it's easier to show. All right. And then, you know, it asks you what size texture you want to create. And this is obviously a pretty small one at 256 by 256. And then what happens is you get this image. Oh, stop. Oh, it created an IFF, my bad. UV snapshot. Send it to my desktop. It's gonna be a test. But I want it to be a, what? From tool settings? No. That's not what I want to do at all. Oh, there's where I want to switch it. I'll make it a JPEG. That's pretty easy. Send it to my desktop. It's going to be a test. No, I don't want it in IFF. Thank you. It's still a JPEG. Awesome. So now, you are so fussy, UV editor. I want this. So now I've got this image, which I can bring into another application like Photoshop, and I can literally paint right on these lines, and then the texture will appear on my geometry. Does that make sense? So this is kind of your guide, and that's why it's so important to have a good UV layout, because otherwise you can't paint your textures well. Does that make sense?
Yeah.
So what we're always doing is trying to create good layout for whatever it is we're making. And some things are very simple to lay out, and some things are very complicated in terms of their layout. So you know, here's a UV layout, somebody's face and head. These are the arms and the torso for the body. That's a leg. That's another leg. Does that make sense? So whatever it is you're modeling, you're going to have to lay out the UVs because there's going to be a texture on it. You're going to do normal mapping on it, way more than likely. And there's some really cool applications like the one you're going to learn next month called Substance Painter, which you have to have the UVs laid out in order to use. And it's just an amazing application for creating textures. But it starts with UV mapping, and you've got to do it. Does that make sense at all, why we're doing it? Okay, it is very important. Some people really don't like UV mapping. I think it's kind of relaxing because you can listen to music and just sort of do it. And once you got all happy squares, you're good. But just like modeling, it is meticulous and it is time consuming. It takes a lot of time to have a good layout. Like it takes a lot of time to create a nice model. Same thing holds true. So just something you got to do. You don't have to love it. Just accept it. It's much easier that way. Any questions about the UV mapping? Does that make sense? Okay. All right. So let's take a quick look with the tiny bit of time we've got left at your skill check. So your skill check assignment is we are going to UV map the jar that you built for lecture 3's skill check. So it'll be a fully modeled jar. And what you're going to do is apply a checker pattern to it just like this. And that's all I need you to do. You don't have to make a texture or anything. I just want to see that you can map the jar and apply the checker pattern. Let me see. I want to show you. Here's my jar for UV mapping. And of course, in terms of UV mapping, this object started out life as a cylinder. And this that you're looking at right here, your UV layout, this is the default UV layout for a cylinder. This is not good. Obviously, this is not a straight up cylinder, it's a jar. It's got more detail on it than that. Please do not ever submit an object with this UV layout because that means you didn't do anything. Does that make sense? I know that this is the default layout. You must lay out the UVs. The good news is we've done this like, what, 3 or 4 times now. We should be able to do it. So steps are the same. Assign it a new material, right? Put a checker pattern on it. Change the color. 6 lets you see it. This is obviously bad layout. So I'm going to have to map it, right? The bottom of this thing is a cylinder, or I'm sorry, is a plane. So I can grab the faces of that plane. I'm going to open my editor so you can see it, right? And I'm going to map it with the planer. Set it for Y because that's the axis I want to map it on. And that's the bottom of my jar, right? Happy squares, good job, right? Now, if you look at this, I think I mapped the bottom of the jar and the inside of the jar at the same time, which I think was your question. Can you do that? And it looks like I did, but you can't tell. But if I go to UV mode and I select one UV on my shell, and I hold down the command key and the right mouse button, and you'll see I have the option of 2 UV shell, and this will allow me to select a shell separate from another shell. I see, yes, in fact, I accidentally mapped them both at the same time, but I would not have known that had I not done this before, and kind of get how that works. So anytime you have shells that may be on top of each other, because if you try to grab one, you can't, you move them both. So what you want to do is select a single UV, hold down the command key and the right mouse button, and choose 2 UV shell. And that will allow you to select just one of the shells instead of both of them. All right. So I did the inside of my jar and the bottom, but I would have to select those faces and do a planer for that as well. Now, here's the part that usually confuses people. In terms of this part of the jar, there's an inside and an outside of the jar, and I have to map those separately. So make sure when you're mapping your jar, you select the faces on the outside, right? And in terms of the tool, which tool do you think I would use here? A cylindrical mapping tool, right? Because it's a cylinder. So I do my cylindrical mapping tool, and that maps the outside of my jar, right? But then I also have to map the inside of my jar, and that's going to be a separate map. I can also cylindrical map it because it is also a cylinder, just it's the inside. Does that make sense? That's more of like the layout you're going to need. And what we're going to talk about next class is how I can attach these to each other and make an even better layout. But what I want to see from you guys is, again, make sure I'm seeing happy squares everywhere. I don't want to see the default cylinder layout. And then make sure the squares are the same size on the side as well as the bottom. And then everything, when it's all done, has to fit back into the 0 to 1 space. So make sure you get that stuff in there. Does that make sense? That is a correctly or accurately mapped jar. All righty? Let me just check real quick and make sure. Very cool. All right, any questions? Again, I just did your skill check for you so you can see what it would look like, just to make sure you're all on the right track. But again, the process is just like we did this whole class long. Any questions about the skill check? Yes?
I'm getting the squares, but also the rectangles.
Well, you have to make sure that when you're mapping, you grab all the faces of the thing that you're mapping, and then use the cylindrical mapping tool on the cylindrical parts and the planar mapping tool on the planar parts. If you're looking at the side of your jar and some of your faces look good and some of them don't look good, then you did not select all the faces. Does that make sense? You got to make sure you don't miss anybody, because it is possible to map something, you know, and then let's say, for example, I grab all of these faces, but I forgot that one, and I do my cylindrical mapping tool. It's going to map everybody. It's going to look fabulous, except for right there, because I missed that one. Does that make sense? They are all connected to each other, so I got to make sure I grab them all. So that will definitely lead to that kind of thing. So make sure you got everybody. All right. Any other questions? Awesome. All right. Well, I got to let you go because there's another class coming in, but thank you very much. This was a fairly complicated lecture. We're going to pick it up on Saturday, and we're going to talk about more UV mapping tools and more stuff we can do to improve layout. But let's get started with this stuff and make sure we understand it so we can move on to these other things, which are also really helpful in getting a good layout. So get your sleep Friday night. Make sure you come in on Saturday ready to roll. Yeah, I know, you and me both. Thank you, my digital friends. Alrighty, I will see you guys all on Saturday.
Yeah, we do have zero.